This educational video is to learn about intensities. Let's look into this topic. What is intensity and how it can be measured? Intensity is the vector sum of all the scattering. Peak intensity is the result of lots of electron scattering. Intensities can be measured as either area under peaks, excluding background, or also as peak heights. How does intensities varies? Locations of diffraction peaks are related to d-spacings of families of lattice planes. Besides, relative intensities of diffraction peaks can yield information about arrangement in the crystal lattice structure. The graph shows a qualitative XRD graph of a crystalline material. Usually the strongest peak is set an intensity of 100. What does intensities depend on? Intensities depend on scattering power of atoms and position of atoms. What are the types of scattering in intensities? There are three types of scattering, which is scattering by a unit cell, scattering by an electron, and scattering by an atom. How scattering affects intensity. Intensity can be defined as the energy passing through per unit area per unit time. When plane x equals O, the intensity of scattering light is inversely proportional to the wavelength. This could be observed from the diagram below. Thompson equation can be used to explain how electron scattering intensity takes place. From the equation, I is intensity of incident beams. R is distance from electron to detector. 2 theta is angle between scattering direction and incident beam. The equation shows an inverse square relationship to intensity. The equation is basically a classical radius of electron term. It is also known as polarization factor. What is structural factor? Structural factor is known as the resultant X-ray scattering power of the whole crystal structure. The scattering amplitude, peak and intensity interrelated with structural factor. The red-colored X-ray beams, that are being diffracted on the red planes of indices HK, fulfill the Bragg's law, and in the same manner will behave the blue-colored beams on the blue planes HK as shown in the diagram. The structure factors, F, H, K, L, are the fundamental quantities on which the function of electron density depends. The structure factors calculated with formula are from the known atomic structure, are represented by vectors which consist of modules and phases. How to calculate structural factor? The unit cell scattering factor is called the structure factor, F. The formula is written as such as shown in the box. It shows that intensity is proportional toward the square of structure factor. Presence of additional atoms, ions, molecules can alter the intensities of some of the reflections. The selection of diffraction of a Bravais lattice is present or absent is determined by the value of H, K and L to obtain as odd or even. For example, if the implies that H plus K plus L even, the reflections are only present in BCC. Both the formula is essential in find the square of structure factor, F.
Thank you for watching. Don't forget to like, share and subscribe to the channel.